Hello everyone. So we are going to solve this problem related to the mass attached to a spring. So let's say some mass is attached to a spring and it is released at time t is equals to 0. As t tends to infinity, this mass will become stationary. So that stationary position is called the equilibrium position, and we call the stationary position as x equals to 0. We denote it like this. So now if x denotes the position of the mass, then the positive values of x, let's say if x equals to 2, tells us that mass is 2 unit below the equilibrium position, and the negative value of x tells us that mass is the above the equilibrium position. Okay, so let's now read the question. The position of the mass hanging to a ceiling is given by this. Then x equals to 0 is the equilibrium position, and the ODE model is given by this. Then whichever one of the following statement is true. So we have to solve this ordinary differential equation to get the function which tells us about the position of the mass. So let's say uh, the auxiliary equation of this differential equation will be d square plus 4 equals to 0, and the roots will be plus minus 2i. So the solution will be given by x of t is equals to c1 cos 2t plus c2 sin 2t. Now we can use these initial conditions. So at t is equals to 0, x is 0. So 0 is equals to c1 cos 0 is 1 and sin 0 is 0. So c1 is 0. So if c1 is 0, that means we can eliminate this. So we have c2 sin 2t. Okay. Now using the second condition, if we take the derivative, then we will have c2 2c2 cos 2t. Okay. Then if we put x equals to 0, I will have, sorry, t is equals to 0, then I will have x minus 3 and is equals to 2 c2, because cos 0 is 1, and c2 is equals to minus 3 by 2. Okay, c2 is equals to minus 3 by 2. Now put it here, then we will have x. So the position of the mass is given by this function x of t is equals to minus 3 by 2 sin 2t. Now at t is equals to 0, x is 0, that means it is starting from equilibrium position. So in every option it's saying that it starts moving at t is equals to 0 at equilibrium position, which is of course true, because at t is equals to 0, x is 0. Now does it repeat itself? That's what we have to see. So let's say how many times, like at what time it returns back to the x equals to 0. That's what we want to see. So if we put x of t is equals to 0, then we will get sin 2t is equals to 0, and sin x is 0 when x is equals to n pi. So sin 2t is 0 when 2t is equals to n pi, and now t is equals to n pi by 2, and where n is a integer 1 2 3 4 5 6 7 8. So from here we came to know that after every pi by 2 seconds, that mass crosses the or touches the equilibrium position. So after every pi by 2 seconds, it passes through the equilibrium position. So option A is the correct answer. So that's it for this video, and thank you for watching.